In this video, I will share an experiment to determine self-inductance of a coil by Anderson-Bridge method. According to Faraday law, the induced EMF developed in a circuit due to variation in magnetic flux linked with the circuit is directly proportional to rate of change of magnetic flux linked with the circuit. And magnetic flux linked with a circuit is directly proportional to magnitude of current at the time of observation. So Faraday law becomes EMF proportional to rate of change of current, or we can write EMF is equal to L di over dt, where constant of proportionality L is called self-inductance of the circuit. SI unit of self-inductance L is Henry. Anderson bridge is just a modified Wheatstone bridge. Anderson bridge circuit consists of resistances P and Q of constant value, three variable resistances R, S and small r, and a capacitor C. The coil, self-inductance of which is to be determined, is connected in series with the resistance S, and a headphone is used as a detector for balance point of the bridge. At junction point A, current I from source is divided into three parts, I1, I2 and I3. Current I1 flows through resistance P, current I2 flows through capacitor C and then through resistance R. Current I3 flows through resistance capital R and then passes through coil L and resistance S. At junction point B, currents I1 and I2 combine and total current I1 plus I2 flows through resistance Q. At junction point C, currents I1 plus I2 and I3 combine to give total current I. The bridge is said to be balanced when no current flows through the arm BFD of the circuit. For current through arm BFD to be zero, potential across arm ABC must be equal to potential across arm ADC of the circuit. Comparing the potential across arm ABC with the potential across arm ADC, equation number 1 can be obtained. XL is equal to J omega L represents inductive reactance of coil and J is equal to -1 under the root. Omega is angular frequency of current. L capital is self-inductance of coil that is to be determined. Similarly, for zero current through arm FD of the circuit, potential across arm AF must be equal to potential across arm AD. Comparing the potentials across AF with the potential across AD, equation number 2 can be obtained. Here XC is equal to 1 upon J omega C is capacitive reactance of the capacitor having capacitance C. Substitute the value of I3 from equation number 2 in equation number 1 and obtain equation number 3. Apply Kirchhoff law in closed loop ABFA and obtain equation number 4. Divide equation number 3 by equation number 4 and obtain equation number 5. Compare imaginary parts on left hand side and right hand side of equation number 5 and obtain equation number 6. If resistances P and Q are of equal value, then from equation number 6, expression for self-inductance L can be obtained. Let me introduce the apparatus to be used in this experiment. Out of these three coils, one is to be used. Out of these two capacitors, one is to be used with the help of this switch. This galvanometer is to be used as detector. These three knobs are used for changing resistance small r. These three knobs are used for changing resistance capital R. This knob is used for changing resistance S. Resistance P and Q of 1000 ohm each are internally connected. Make various connections in accordance with the circuit diagram. Some of the connections are already made internally and some are to be made with the help of connecting wires. Connect battery to these terminals. Connect galvanometer to these terminals meant for detector. Connect any one coil of unknown self-inductance to these terminals. With the help of this switch, introduce any one capacitor and note its capacitance value as C. Press this switch and observe deflection in galvanometer. Minimize the deflection in galvanometer by randomly varying resistance R and S. Note the values of resistance R and S for which deflection in galvanometer is almost zero. Now replace the battery with source of AC supply. Replace galvanometer with headphone and observe sound heard from headphone. Keep the values of resistance P, Q, R and S same. Adjust the value of resistance r till sound heard from headphone has almost zero intensity. Note the value of resistance r. Using the noted values of resistance P, Q, R, S and r and capacitance of the capacitor C, calculate self-inductance of the coil by using the relation L equal to CR into P plus 2R. Thank you.